Okay, everybody, this is section 25.2, the ambiguous case of the law of sines. This ambiguous case is for the SSA triangles. That's when you're given two sides and an angle, but it's two sides and a non-included angle. And what that will look like is you might know angle A, but you will also know its opposite side. So you will know all of one thing here. You'll know the A and the little a. And then you'll know one other side. So let's say you know B. So you'll know two sides and a non-included angle. It looks something like this. Now, if this is obtuse, if this is an obtuse angle, it's case 1 and 2. So if you have an obtuse angle, if A is obtuse right here, you should remember from geometry that if A is big angle, so it might look something, so let's make it look like this. If A is the obtuse angle, so we'll say like 110. We'll say that's 110. Oops, can't do that. We'll say this is 110 degrees. Well, then this side that's opposite has to be the biggest side, so because that's the biggest angle. These other two angles will be smaller because together they're 180. So together these only have a total of 70. So they're very small angles. So this say if this was 11, that's side A, then side B could be anything smaller than 11. So we'll say 7, and that would be legal. If this is 110, this has to be the largest side. So that's what this one right here is saying. If A is obtuse, then its opposite side must be greater than any of the other sides, B or C. That could be a B or a C. So here's an example right here. A is obtuse. So again, fill in a big angle. Fill in, that looks like to me, here's 90. Let's say that's 120. So as long as this side right here is 10 and this side is like a 8, that means A is greater than B, you're good. And there's one triangle for that. Now, if A is obtuse, and they say this is 7 and this is 11, well, that can't be. If this is the largest angle, that has to be the largest side. And in this case, it doesn't matter. So what this means is, here's the drawing for it. If this A is obtuse and A is smaller than B, you wouldn't even be able to draw the triangle. So case 1, obtuse. If it's obtuse, if the angle that's given is obtuse, just look straight across from it. That has to be the largest side. So A has to be greater than B for you to have one triangle. If not, you will have no triangles exist. So if you tried to do something like this, if you even, like, let's say you don't even understand these things at all over here, and you try to set up sine of 110 over 7 equals sine of B over 11, it's going to give you no answer on the calculator. I'm going to show you. So even if you don't understand these boxes and you just do law of sines in general, it's going to give you an error sign. So you have sine of 110 times 11. Oops, I didn't do times. Times 11. And then you divide by 7. And then you take arc sine, which, by the way, see how it's already over 1, 1.47? Sine can't be over 1, so I already know there's no error. I already know it's an error. So arc sine, second answer, it says quit. Value entered is not allowed in this function or command. Okay? Radian mode, tan pi over 2. All this up. It's an error sign. So even if you don't understand these boxes, you'll get an error sign when you need to get an error sign if there's no triangles. Okay, so that's case 1, obtuse. All the other 4 boxes is when A is acute. Okay, so let's look at the top here. So you're going to be given A and B, two sides, and an angle. So notice again, you will be given an angle across from one of these two sides. You'll either be given angle A or angle B if they give you A and B. If they give you A and C, then you'd have to know angle A or angle C. You have to know the angle across from one of the given sides for this to be SSA case. Now, height or altitude comes into play on this next part. The altitude or the height is found by taking B sine A. Okay, so for example, I'm going to draw another triangle up here. A, B, C. And we're going to draw an altitude, and we're going to call this H. So this is B right here, and this is A, and this is little C. So if I just wanted to concentrate on this triangle right here, this one right here, and I said find H, and you did SOHCAHTOA, like literally we're ignoring this triangle right here. So I said find H using SOHCAHTOA. You could say sine of A is equal to height over B, or opposite over hypotenuse. Do you guys understand that? Sine of A, again, we're ignoring it. Sine of A is opposite H over hypotenuse B. And then if we solve for B, we'd get, actually if we solve for H, we'd cross multiply this and we get H equals B sine A. That's where this is coming from right here. Okay, so whenever you're trying to find an altitude, you just do the side. Now remember, there's two sides. You use the side that's not part of this relationship here. Big mama, little mama. Like mama, daughter. This is just a friend. No, that you do not know that angle. So you take the side that's not part of being across from these two and multiply it by the sine of the angle given. And if this height is greater than A, side A, there is no triangle. So it kind of resembles this. If your height is bigger than the opposite side, the given angle, you would not be able to draw this triangle. So if the height is too big, it's like you would have a leg that can never hit the ground. Like this is side A. That's what it would look like. The side would never. So the height cannot be bigger than side A. And how do you find height? Height is just B sine A. So you're going to look at this. So if side A is less than B sine A, there is no triangle. Now, if A is acute, if the angle A is acute, and its side that's opposite that, A, is greater than B, there's always one triangle. So how do you know when there's two triangles? It's when, okay, first of all, here's another case. When A is acute and A and H are the same, like this, then you actually have a right triangle. If A and H are ever the same, if A is ever equal to B sine A, you have a right triangle, and that means you have one triangle. This is when you know you have two. This is when you really have to pay attention to. Of all of them, if you can know this one, it'll save you some points on a test because you don't want to forget this. Check. If the height, which by the way is B sine A, is less than the A, which is the side opposite the given angle, and is less than that friend side, the one that doesn't have the opposite angle. So basically, if A is greater than the height and A is less than B, you have two triangles. So it kind of looks like this. Very hard to understand, but this right here is what it says in words. In order to have two triangles, the following must be true. Height must be less than the opposite side, which is less than the adjacent side. In other words, B sine A is less than A is less than B. So here's how I remember to do this conjunction. So again, we're given A, B, and angle A. Take the side that doesn't have the relationship of angle and a side across from it. Take the other side and put it on the ends like this. Then put in your inequalities, less than and less than. They always go point to the left because we want the height to be the smallest thing here. And then the middle is the other side, A. So you have side, side, and then the other side goes in the middle. Now the height, which is B sine A, that is going to go out front. You just put the sine A with that thing. So this is your height. You want the height to be less than A, which is the side across from angle A. And you want that A right here to be less than this. If that is ever true, you have two triangles, and you have to try both cases. Now, in this conjunction, there's two conjunctions, there's two inequalities here. If the first one says if the height happens to be greater than the opposite side, so if the first case of this, if this part right here is the false part, if this part is false, then you have this right here. If the first part is false, then no triangle exists at all. So if the height is greater than A, that would be this. If the height is greater than A, you would have this triangle right here. So if the first part is false of this, so let me write this again, B sine A less than B. If this part is false, In other words, the height is greater than A, you have no triangles at all. But if it's this part that's false, if this part is false, just this part, then one triangle exists. Because it would be greater than, and you would have one triangle exist. I'm doing a video. What do you need?
I was just going to ask what the remind thing was. I never got it.
You have to go into your Google Classroom and do the quizzing.
No, like the remind.
Code?
Yeah.
I can't do it right now because I'm in the middle of a video. Okay, so we're going to do this thing right here. All right. Ignore the red triangles from my other side. We're going to determine how many triangles, and we're going to do it all by using this little conjunction from the other side. Notice the B's are on the outside, A's in the middle, and then sine A always goes with the first one. If all this is true, there's two triangles. If this is false, there's one. If this is false, there's none. False, none. False, one. All true, two. All true, two. Okay, first one. All right, so here's that B is 10. So we're going to put the 10 on the outsides like this. We're going to put the other side in the middle. Put in your conjunctions, your inequalities like this. And then you're going to put sine 30 right here. Sine 30 is 1/2. So you can punch this in your calculator, but sine 30 is 1/2. So this is 5, is less than 5, is less than 10. So this part is true, but this part is false. If the height is equal to A, I think there was something on that one. If the height is equal to A, where is it? Right here. If the height is equal to A, there's one triangle. So this is not exactly false. This is not exactly false, but it's not like, if these are ever equal, I should have said that. If B sine A is ever equal to A, there's one triangle as well. So there's one triangle if this is false. There's one triangle if these are equal, and there's no triangles if this is absolutely, like this number right here is greater than this number. I know this is very confusing, but this one just happens to be a special case. It's a right triangle. So right triangles mean there's one triangle. Anytime these are equal, height, because this is height. This first one is height. Height is equal to A. It's this little box right here on the other side. All right, so now that I've thoroughly confused you, let's try this one. All right, so which side is the stranger? This A, see how A doesn't have anything to do with the C's? We're going to put 7s on the ends, 18 in the middle, and put sine of 75 with the first one. And put your inequalities. So on your calculator, we're going to take, I can already tell that this one's false. 18 is not less than 7, right? So because of that, there should be one triangle. In other words, it's saying that the opposite side, 18, if that's greater than 7, there's just one triangle. It can never be 2. But sine 75, if you want to do 7 sine 75, I want to make sure I'm in error. Make sure I'm in degrees. Okay. So if you did 7 times sine 75, you get 6.76. So this is 6.76. So this is true. 6.76 is less than 18. So you have at least one triangle at this point. So you keep going. Well, this part is false. So you don't have 2, just have 1. Okay, this next one, okay, the oddball one, 75. This is the adjacent side. Put that on around the ends. You put 50 in the middle. And put sine of 100 degrees. This is an angle. Sine of 100 degrees in the front. So it looks like 50 is less than 75, so that's good. We're checking this first part. 75 times sine of 100. And you get 73.86. Is that less than 50? Nope. So there are no triangles. What do you need?
Nothing. I'm
Okay, can you shut that door?
Yeah.
And then this one, C, B, and C. So the oddball, you see how you have C and little c? B is called the adjacent side. That's when it doesn't have the angle opposite. Put those on the ends. Put 21 in the middle. And put sine of 40 here. So 25 sine of 40 is 16. Is that less than 21? Yes. So there's at least one. Is 21 less than 25? Yes. All parts of this is true. So this one has two triangles. Hopefully you're starting to catch on now. AAC, the oddball. We have big A, little a. C is the adjacent side. So start with C, 45, 45. Put side 10 in the middle and put sine 63 with the first one. Put in your less than signs. So 45 times sine of 63 is 40.09. So we'll say 40.1. Is 40.1 less than 10? No. See, that's a no. It's false. It is not less than 10. It is greater than 10. So since that is false, there are 0 triangles. Oddball ones is 90, 90, 90, 90, 85, sine 70. So 90 sine 70 is 84.6. Is that less than 85? Yes. That means there's at least one. Is that less than 90? Yes. Two triangles. And the last one, 7.5, 7.5, and 6. Sine of 100. Again, we picked 7.5 on the ends because it's the A. It's the, you have big C, little c, and then you have this other side. It's the other side that goes on the outsides. So anyway, 7.5 times sine of 100 is 7.4. Is 7.4 less than 6? No, it's not. This is false. Whenever the first part's false, it is 0 triangles. That means you don't have to do any work. So here we go. This one right here. They give you pictures, 42, 22, and 18. I would assume, since they've given you two pictures here, that there are two solutions for this. So let's just check. Which one's the oddball, the adjacent side? 22. Put that on the ends. Put the 18 in the middle. Sine of 42. So 22 sine of 42 is 14.7. Is 14.7 less than 18? Yes. There's at least one. Is 18 less than 22? Yes, there are two triangles. And these are the pictures. So when you have two triangles, you draw two of them. You draw it with the 42, 18, and 22. This is going to be the acute triangle. And then you draw one where you're going to have an obtuse angle. This angle right here is going to be obtuse. This angle A is 42, but this angle B is going to be a very large angle. It's going to be the obtuse triangle. And why do you think this works? You have to remember that sine is positive in this quadrant and in this quadrant. So like a sine of 30 here is the same thing as a sine of 150 here. So if 30 was the angle you find first, 150 would be the other one because they're the same value. Sine of 30 is 1/2, sine of 150 is 1/2. They have the same value. So two different angles could work when using law of sines. So we're going to solve for both triangles. So we're going to solve for angle B, angle C, and side C. So the first thing we're going to do law of sines here. So we're going to go sine of 42 over 18 is equal to sine angle B, we'll call B1, over 22. The reason we're calling this as B1 is because we're going to have different angles over here labeled. So we call this B2 and C2, and this one B1 and C1. Now, everything's going to go from this angle B. The very first angle you find is the most important one because as soon as you find this, you're going to go straight to the second triangle and find B2 by using the knowledge that sine is positive in both these quadrants. So let's start by cross multiplying. Okay, so we're going to have sine of 42 times 22 equals divided by 18 equals. Now you get a decimal, which is fine because we're going to do arc sine now. So it's arc sine of 0.8178. So we're going to take arc sine. Now, for those people that have the highlighting feature, just go up and highlight that and press equals, and it comes and it copies it right there. Arc sine of the previous answer is 54.9. So angle B1 is 54.9 degrees. I'm going to circle this. That's our first answer, and I'm going to put this in right here. 54.9 degrees. Now, this angle B right here that you can't really even draw in there because it's such a small triangle is going to have the same value. So sine of 54.9 is going to have the same value as what? So sine of 54 is about right here. Okay, well, what is it in this quadrant? Because sine's positive in both quadrants. So you're going to take 180 minus 54.9 to figure out what this angle right here is. So 180 minus 54.9 is 125.1. So 125.1 is at this angle and 54.9. But if you did the sine of both, these are the exact same value. So they're interchangeable. So right away, B2 is going to be 125.1 degrees. We've already found our other B without doing any law of sines or anything. It's just going to be that you should know that sine is positive in first and second quadrant. So if you get 54.9, then 180 minus this is that. And that's going to go right here. 125.1 degrees goes right there. So if I do this a little bit bigger, this is 125.1, and then this one's still 42. This is still 22, this is still 18. So now we can go back to the first triangle, go back to your first triangle, and find C1. So C1, if you can see right here, C1 is equal to 180 minus 42 and minus 54.9. Because you have two angles, and the third one is 180 minus all this. So we have 180 minus 42, that was the given angle, and 54.9, which was the one we just found, for an 83.1. So I put that right here, 83.1, and that's what C1 is. I need to organize my work a little bit. So we have B1 is 54.9, C1 is 83.1, and now we're going to find side C by using law of sines again. So side C. So right now, to find side C, I'm going to use the given angle, sine 42 over 18 equals sine of 83.1 over little c. So we're going to cross multiply that. Sine of 83.1 times 18 equals, divided by sine 42, 26.7. And we weren't solving for an angle, so we don't have to do that second sine or anything. So these are your first three sides, first three sides of triangle 1. Sorry about that. That's triangle 1. But we have to go over here to triangle 2 and complete this one. So far in this one, we know that B2 is 125.1. So to get C2, we have to take 180 minus 42 degrees, which was given, minus the 125.1 that we found by finding that second quadrant angle. So we got 42 minus that big obtuse angle, which is 12.9. So C2 is 12.9 degrees. And I would put that right here, 12.9. See where I put that? 12.9. So all three of my angles are known. We got two sides that were given from the beginning. And now side C on this one. We're going to go sine 42 over 18. Now notice this is the same ratio I used over here. Okay, it's no different. But this side C angle is different. So C2. So sine of the 12.9, that's side C way up here. Goodness, I can't see. Side C way up here, 12.9, over side C. Cross multiply. Sine of 12.9 times 18 equals, divided by sine 42 equals 6. So little c is 6. So C2 was 12.9 degrees, and little c is 6. So as you can see, this is a ton of work, and a problem like this would be worth 12 points on a test. 6 points for this one, 6 points for this one. So if you don't check for 2 and you only did 1, you would miss 6 points for not checking the second set of answers. Okay, so this one. 2 posts are located 300 yards away, and the angles from the post to the third one are 75 and 68. About how much fencing does Joquan need? I'm not sure if that's how you say his name. Sorry about if I butchered that name. All right, so I'm going to just use I like putting A, B's, and C's in here. All right, so we need to know the sides. In order to find perimeter, how much fencing, we need to know perimeter. Our final answer is going to be side A plus side B plus side C. And the only side that I know right now is side C, which is 300. So we have to find side A and side B. So let's start by finding our third angle, which is 180 minus 75 minus 68. 37. Put that in. And now we can use this ratio to find the other two sides. Using law of sines. So we're going to go sine 75 over side A. So we're going to go sine 75 times 300 divided by sine 37 for 481.5. So this side right here is 481.5. I'm going to fill that in. A is 481.5. Now to find B, we're going to take that same ratio, sine 37 over 300. And this time we're going to use the 68, sine 68 over side B. So we're going to go sine 68 times 300 divided by sine 37 for 462.2. Perimeter would be 481.5 plus 462.2 plus 300. These are some long notes, Amari.
It's okay.
Did you want to talk or anything?
No.
Just hanging out in here?
Yeah.
How's things going with you know who?
I don't see her.
You don't? So everything's fine then?
Yeah, I guess.
And that's perimeter. And this was in yards, so we should definitely include the units for that. Yards. 1243.7 yards. So if you were going to the store, you probably wouldn't buy 0.7. You'd probably round that up to about 1,244 yards of fencing. And in case you mess up, probably maybe even an extra yard. 1,245 would probably be a good one to buy. Solve the 2 solution ambiguous case situations. Oh, this is another 2 one. Aren't you guys excited? So here's the oddball side, 120. Put that here and here. Put the other side in the middle. And put sine of 50 here. 120 sine 50 is 91.9. That is less than 100. True. That means there's at least one. That is less than 120, so there are 2 triangles. So immediately you should draw 2 triangles. See ya. A, B, C. 50 degrees. 100, and side B is 120. Same thing here, A, B, C. I don't care. I know this one's going to be obtuse, but I'm still drawing them the same. I'm not drawing them to scale. All right, so let's call this one B1 and A1 and call this A2 and B2, and we'll call this one side A2 and call this side A1. So we're going to go sine 50 over 100 equals sine of B1 over 120. So this is sine 50 times 120 divided by 100. Now, since we're finding an angle, we have to press second sine, highlight, answer, 66.8. So this one right here is 66.8 degrees, and that's B1. So B1 is 66.8 degrees. Immediately, we're going to go over here and find B2. Okay, the way we do that is we're going to take 180 minus this, because triangle-wise, this is 66.8. We need to find the second quadrant one that has the same value. You do that by taking 180 minus this. So it's 180 minus 66.8 for 113.2. And we fill that in. That's the obtuse one. So when you do these, you get an acute, and then you'll get an obtuse. Acute and obtuse. This is this. 180 minus that is this. So B2 is one of your answers. B1 is one of your answers. Now, the rest of these are not too bad. So to find A, you take 180 minus 66.8 minus 50 for 63.2. So A1 is 180 minus...
How old is it? And how accurate is it?
So A1 is 63.2. Side A, we're going to do all signs. So we're going to go sine of 50 over 100 equals sine of 63.2 over A1.
What did she say?
116.5. Does that make sense? The largest angle is 66.8. That should be the largest side. Medium angle, medium side. So that makes sense. So 116.5. And then find this little side A. First of all, we have to find angle 2. We have to do 180 minus 113.2 minus 50 is 16.8. That's going to be a small angle because that's a big one. So this other one should be small. So A2 is 16.8 degrees. And to find side A, you're going to take sine of 50 over 100 equals sine of 16.8 over A2.
I feel like you can do really good at all this.
37.7. I'm just going to draw this. Give me 1 second. The angle of elevation, 50 yards away from a tree to the top of a tree. The angle of elevation, 50 yards away from a tree to the top of the tree is 23 degrees. The tree leans 4 degrees away from the vertical in the opposite the point 50. Okay, so we got to redraw this. So 50 is going to lean 4 degrees away. 23. So right here, this is 90 plus 4. So this whole thing is 94. How tall is the tree? The tree is here. I don't have time to finish this, but I think you guys pointed the notes.